My name is Kate Gregory. We were just talking. I've been paid to program since 1979. It's a long time. Seen a lot of languages in that time, and still interested in seeing current ones. I'm strongly associated with C++, but I'm also part of the Carbon Language Project. So I talk about the future of programming languages quite a lot.
And why do you think I asked you to be on the panel?
Why did you ask me to be on the panel? I didn't step backwards quickly enough when I saw you come around the corner.
A good answer.
So my name is Nico Josuttis. I was in the room when the first C++ standard was finished in 1998? Okay. So it's partially all my fault. That time I loved C++, now I hate it. And the reason? The reason why I proposed this panel because I like to complain.
Okay, my name is Kevlin Henney. People have been paying me to do stuff with code since the late 80s, and that feels far too long. Working with C++, I think first C++ compiler I used was 1990. I have a continuing love-hate relationship with the language. I deal with a lot of other languages, so I get to see what other languages and their processes look like. I've been in and out of the committee a number of times. Every now and then I think, okay, here's something, or, oh, I've got a client that really, yeah, okay, I'm back doing C++ again. Okay, oh my goodness, what's this? I need to go back on the committee, and then I'll walk away shaking my head. There's a kind of historical cycle there. Why am I here? Why did Bryce ask me? Because he needed people on the panel. He was sitting in my talk yesterday. I was in such a good mood at the end of the panel. He probably knew he could get a yes out of me because I was on a high, and he was also between me and the door.
Hello, everybody. I'm Vittorio Romeo. I'm the young person of the panel. To be fair. you brought this upon yourselves.
It's true. It's true. But that was when the mic was off.
That's fair enough. I mean, this can be off the record, right? We said that. So let me start again. Hello, everybody. I'm Vittorio Romeo. I've been working on Bloomberg for more than 6 years, mostly working on teaching modern C++ nowadays. I am involved in the committee. I'm part of the Italian national body. And I believe that Bryce invited me here because other than enjoying complaining, I also wrote a paper about epochs, which is a language evolution mechanism a while ago. Didn't really go anywhere in that current form, but there's still a lot of space that can be explored, and maybe we can talk about that as a way of evolving C++ while retaining backwards compatibility.
All right, now let's dive into some questions. And I see the audience has already asked some pretty good ones. And I won't give an exact answer as to why I asked all of you here, but I will say that one thing that all the panelists have in common is that they are all, in some way, teachers of programming languages and in C++ in particular. And I thought that would bring an interesting perspective. So, question number 1. What is the greatest challenge facing C++ today? And do you believe it can be solved? And if so, how?
I have the mic, so I'll start. I believe the greatest challenge of C++ is being able to evolve while also breaking backwards compatibility. There are many things in the language that we keep carrying over standard after standard, and we keep accumulating baggage, accumulating ways of doing things. There are like hundreds ways you could initialize a variable in C++ and things like that, right? And the reason why we cannot clean up or simplify this sort of issues is because we want to retain as much backwards compatibility as possible. So I do believe it can be solved. And as I delineated in my paper a while ago, modules give us a way of sort of tweaking the translation from source level syntax to AST in a way that's isolated from the rest of the program. So we could basically say, hey, this module is a brand new syntax for C++. It will compile to a compatible IST, a compatible IR, and we can disallow any form of initialization except curly braces, or we can disallow the most vexing parts and things like that. So at least on syntactical level, that's a way we can handle it. Regarding ABI, I don't have any good suggestion, but that's also another problem that should be tackled in order to evolve the language and break things and make them better.
Copy paste. I thought we've got beyond hashing. Oh yeah, modules. How's that going, everyone? Yeah. So that's the thing, is the biggest obstacle to C++ is the past. Can we solve that? No. The laws of physics are fairly clear on that one. We cannot go back in time and change everything. And we are just accumulating crap, and we're adding more crap as well. And a lot of the members of the committee do not realize they are adding more crap. What they're doing is they're solving pet projects and then saying no to other things. So I've just immediately thrown in a complex dynamic there, which is potentially provocative and political. But is it going to be solved? Absolutely not. C++ is going to continue getting more complex. Somebody will actually have to be an architect with the language to make a radical shift in the past. What we all call that is another programming language.
Copy all. I think C++ is now fundamentally broken. I think that...
Tell us what you think.
Come on now. Don't hold back.
I think that the entropy of the language is now too big. I don't think we can solve that. We could solve that technically if we would like to do that. I think the C++ Standard Committee is not willing to solve that. And the reason is we have no common sense and no common direction where this language should be in 10 years. So take the next one. It's 50 years old. There's no problem with taking the next programming language. The only problem is we don't know which one. There is none that can replace this. So this is a dead language for the next 20 years.
Well, they've done a good job about the handcuffs of backwards compatibility. I think another problem that C++ has is the community. Something I've been working on for a bunch of years about wanting to make C++ more welcoming and inclusive. And there have been some big strides. We're doing better than we were, but there's still some very toxic pockets of our community that are celebrated, right? Like in a talk some years ago, I asked, is it important to your ego that you're really good at a very complicated language? And you know what? For a lot of us, it really is. Like the more difficult, the better. Keep those script kiddies out, and only really, really smart people are allowed in our language. That's not how you grow a language.
Yes. Anybody on the panel have a follow-up? Is there anybody in the audience who has a follow-up? I have a microphone. Anyone's interested? I don't see so. So let me ask you, Nico. Okay, so what? You said that we don't know yet what the next language is going to be. But which ones are you interested in? Which ones are you learning?
None. None. I'm 60. I sell a hell lot of books describing the nonsense and bullshit we now standardize. And that's the end of my professional life. I have other things to do. Thank you very much.
That's probably the wiser answer. I'm part of the Carbon Project because I think that it's an interesting way to. One of Carbon's kind of founding principles is it's okay to break things, and we're just gonna figure out a way in code to fix that for you. And that's a complete 180 of how C++ approaches compatibility, and I think it's really interesting to see where that goes. Don't know if it makes a language yet or not. Probably find out this year.
Can I just say? So I would go to Carbon if in 10 years it's worth it. No question on that. We had other approaches to replace C++.
Yeah.
So the question is, where are we in 10 years?
I like Rust. I'm sorry if somebody feels offended by this statement. I kind of feel like projects like Carbon and CPP2 by Herb Sutter, they are interesting. However, they're in that uncanny valley where it's like trying to fix some stuff about C++, but not radically improving the fundamentals, that I feel like I'd rather spend my time either fixing C++ itself or moving to another language. So while I'm happy that these projects are out, I don't really see them as a viable path towards the future. I'm all up for adopting new languages. Like, I like Rust for a lot of reasons, and I think it is, even today, a very good choice for new projects. And it also has a decent story in terms of backwards of compatibility with C++. It's easy to interoperate. But yeah, it's hard to say if this is going to be true in 10 years. There's also other interesting projects like, for example, the Zig language, or more game development-oriented languages like Jai that are coming out or being developed right now. So it might be that every domain has its own sort of language. That's another possible solution. And one question I'd like to pose to the rest of the panel, also the audience, is Bryce mentioned that one of the questions was, what makes a language successful? My question is, what does it mean to be successful? Is it popularity? Is it the amount of revenue generated? Are you successful with a language if you build good software with it? Can we say that the language that's used for a single project by a single person, and this project is used by the entire universe, is successful? Or what is the criteria for success?
That's a really good answer. I wish I'd said all of that, but but yeah, that saves me having to say a bunch of stuff. I think it is interesting that, first of all, one thing that might not be clear is I still enjoy using C++. I mean, I diss it at every level, but every single language I use, I will disrespect it at some level deeply and say bad things about it. Let's be very clear about that. But that whole thing about what are the other languages? There's loads of other languages. We're kind of in a Cambrian explosion of languages. So the idea of there's going to be one dominant language, one dominant paradigm, that feels very, very, I don't know, 20th century. I think we left that behind a few years ago. I don't think in 10 years' time, there isn't going to be a dominant language, with the possible exception of JavaScript. No, that's not a suggestion. Your questions about what defines success, I mean, JavaScript, honestly. There are a lot of criteria. So what we're looking at in 10 years' time, C++ is still going to be most likely, it's certainly be in the top 20 popular programming languages. It will be in the top 10 programming languages. It may or may not be in the top 5. I mean, it's in the middle point of the top 5 at the moment. But it won't be outside that because of all the existing code. It just can't be outside that. It's a critical mass. You know those pictures of the supermassive black holes? Yeah, it's like that. They just draw in matter. There's an accretion disk, and there's also an awful lot of radiation. Okay, and that's the thing. It's going to keep on going. But that basically means that if you've got a career in C++, if that's your thing, in 10 years' time, your job is still probably safe. The main threat is from Bryce. AI, software engineering. So that's the major threat. It's not actually from other languages. It is the way that we develop software is far greater threat, potentially, to the status quo. But I would say that in 10 years' time, you will be happy in your legacy C++ because that's what it's going to be. That's where the language is heading at the moment. That's where it already is, but it's just going to do more of that.
I don't see that C++ is in 10 years below the top 5 because we have no replacement for that available. None. Really none. Rust. But you mean to become a general purpose programming language, which is used by millions of programmers. It has to get some maturity in everything, in usage, in knowledge, in tools, etc.
But we don't need C++.
Yeah, but tell me the language that can take this role. No.
No. You misunderstand how languages work. Languages do not. We don't need a replacement for the space that C++ is in. The way that languages work. I mean, okay, so let's go back 25 years. Let's talk about the languages that were dominant on the web. They weren't really. The point is that what happens is we open up new spaces. Languages move into those. We don't need a replacement for C++. We don't need something in that space. We have loads of general-purpose programming languages. C++ is not a general-purpose programming language. There's plenty of those around. We don't need another one of those, but we'll get them. We will get them. If you mean what would be a general-purpose systems programming language, that's a much more specific question. But you don't need everybody systems programming. Everybody's proved that that's not what they can do. We already know that most people can't systems program. We also know we don't need that many systems programmers. The stack is all the way up here. C++ is happiest down here. We don't need to move into that. That's why C++ will move down out of the top 5, because the idea that a systems programming language is going to be in the top 5 Not going to happen. Yeah, 10 years' time, the top 5 languages, there will not be a systems programming language in there, except possibly C.
So in the early days of Java, people used to say to me, is Java going to kill C++? Like, to hear that as a question now, right? But people were really worried.
What is Java?
Yeah, really. And I would say, did C++ kill COBOL? Right? Like, these are all still here. And people will use whatever they need to use. But I think the point about tools and libraries and training and books and all of that is super important. Because you can invent the best language ever. It needs that ecosystem around it in order for it to gain widespread acceptance. And some of that is pure luck. You know, that someone feels like, oh, I could do a course on that. I wonder what that's like. I think I'll write a circle book, you know, like then suddenly that enables people to adopt it.
Do programming languages have a natural lifespan? Is it just in the nature of programming languages that over time they grow and increase in complexity and they gain backwards compatibility concerns and then eventually there is inevitable decline?
Yes. They live unlimited forever.
Yeah, basically they become moribund. In other words, they reach a point beyond which they're never actually truly going to die. Programming languages relatively rarely die, although people love to say this language, C++ is never going to, they just stick around. They just have a really long tail. But most languages don't even get to that point. That's what characterizes, if we have to say anything about success, is a continued community in some way. And so I was surprised to see just the other day a whole article on programming in PL1 and dealing with stuff like that was written in the last 12 months and was relevant to a particular target audience. I regard that language not as dead, but as moribund. It's kind of in its long tail. But C++ has got a long way to go before it gets to that. It's going to be, you know, Nico and I can argue about top 5 versus top 10, but we're not exactly arguing that it's going to drop out of the top 20. You know, that's, you know, this is a small question degree. So C++ is definitely very much here to stay. But the accumulation of complexity, that seems to be an issue that any language that has been, it becomes a victim of its own success, or, you know, fails to achieve that success and just becomes a victim of anonymity.
Where would you put C in this assessment? C has been around for a long time. It is evolving, but very cautiously, very slowly. Like the future version of C is actually going to get const expert, auto, null pointer, is going to get a bunch of cool stuff. But how is C able to stay so simple, still evolve, and not fall into the same pit that C++ is falling into?
That is a great question, because the universe is made out of C. I mean, anybody who was in my talk yesterday, that's the lowest level. We don't know. I mean, people talk about quantum mechanics and stuff like, no, it's C. That's the lowest level. You cannot go below that. That is the unification of all physics. But yeah, C is still in there. It's still a fighting chance. It's in the top 5. It's, you know, the language that is most likely to knock C is Rust, funnily enough. Curiously enough, people talk about C++ versus Rust. The one potential threat to C is actually, I think, Rust at the moment. But again, I don't see that as a major threat. There's a lot of stuff at this level that exists in C. The massively conservative attitude that it has, in other words, there needs to be a language that has that attitude. There needs to be something there. There needs to be a solid foundation. And it just turned out that that foundation was C. So it's probably not going to change that much. It's just going to continue kind of evolving, still relatively popular. And
it's an exception to the rule of ending up.
I think if you try and look at languages, I mean, it is quite complex. I mean, you know, if you ever look at the original C programming language, first and second edition, C is a small language and it's not well served by a large book. My goodness, have you seen the complexity of C? By C++ standards, it's trivial, but by pretty much any other language, it's actually quite complex. C is a very complex language by comparison with where it started, but on a relative scale, it is quite simple compared to C++. But I think there is the need, if we look at languages as an ecosystem or as a layered system, that's probably better. If we look at understanding a community of languages, there needs to be a language that is like C, and at the moment C is pretty much in that place. Slowly moving.
I don't think C is a general purpose programming language. I think it's an imperative pure imperative programming language. It's a better way to write portable assembler. And the biggest problem with C is it does not scale. If you don't know why, come to the lightning talks. And so therefore it has a special role. I mean, it's by far the best portable assembler code we have. And that there's nothing else that fulfills this role, and therefore it will have this role forever. It's the lingua franca between different programming languages. So when we talk about C++ and other languages, we are, I think, on a higher level. Yeah. And then the question is, what do we have there as a general purpose programming language? Yeah. So that's why I think C is special.
Why is there so much resistance to making breaking changes in the C++ committee? Is this something that is unique to C++? We often talk about this as being one of the things that is perceived as limiting C++'s ability to become better, that we are concerned about backwards compatibility. But why are we so concerned? Is this a uniquely C++ problem?
I'm not on the committee, but we just said the reason C++ will never die is because there's so many millions or billions of lines of code out there written by millions of programmers. And that's also why they don't want to break any of that, right? If you don't plan from the beginning to be able to change the defaults, then you can't come back later and try to do it. So it'd be wonderful if we could say, you know what, now constructors are all explicit unless you mark them implicit. And here's a tool that will clang tidy, basically, your code to make that work. Nope, you can't do that because you broke someone who used that keyword for a variable name or for a function name or I don't know, whatever. And that's it. That's like the magic incantation that makes you stop suggesting things. Nope, can't do that to break someone's code. Okay, too bad.
What I see is that the reason we cannot break backward compatibility are the compiler vendors. So whenever we discuss that, then they say, well, we have the problem. Who pays us to deal with the problem? Because then when they ship the next version, they get all the bug reports and they have to deal with them. And nobody pays them for that. The second problem is, it would be a great experiment if we would decide in the C++ standard committee that we now, in one version, break backward compatibility and then discuss where. So we have 200 different opinions where this programming language should go, and we have 300 different opinions what we should break. Well, everything except what I do is the usual answer. And everything is needed. So we had this discussion. I've been in this discussion, even in the standard committee, again and again and again and again. We have a disease, and the disease is we will not break code, existing code. And by the way, we know at the same time, in the standard committee, we say most of the C++ code is not written yet. So we know that. But we don't have the courage, and we don't have the money and the resources to deal with breaking backward compatibility. That's a problem.
I think this is an interesting one because actually, first of all, is to understand the degree to which C++ is prepared to break things and break with backward compatibility now is actually, it's quite big compared with what it used to be. But it also tells us about the differing role of languages and language standards. So back in the 90s, if you wanted to do something that involved adding a keyword, oh wow, that was almost impossible. These days, adding a keyword, oh good heavens, yeah, go ahead, do it. That's what it feels like in comparison to the 1990s. If you just go through each of the standard sets, in fact, start with the annotated reference manual, start there, C++ 98 and then go through each standard and look at the rate of change of addition of keywords. It's pretty radical. So I'm not saying that C++ is evolving as rapidly as other languages or making as many breaking changes, but on its own terms, it has actually changed. It's not moving as slowly. It is breaking stuff more than it would have done, just not as much as perhaps we might like. And that's the balance. There's a balance here, and there's a lot that restrains it. But I think there's also another thing, which is the role. Why do we have an ISO standard? Why is that where the work happens? Now, look around at the moment. Look at every single new programming language and look at who is building that. Well, the most common model now is the foundation model. Is that better or worse than an international standard? What was the purpose? Why do we standardize languages? It was originally because there was differing practice. Fortran and COBOL were the progenitors of all of this. And it's the idea of we want to know that something will build because there's so much diversity between these things. But they also standardized existing practice. That was the byword. Come C89, there were a few little inventions, but mostly it was standardizing existing practice. And that attitude also carried over into C++. That is not at all what C++ does, as a committee does now. There is no standardization of existing practice. That's not what happens. That stopped in the 90s. But that is the purpose of international standards by and large. So it's kind of in the wrong body, so to speak. The spirit is in the wrong body. It's like a crazy science fiction mix-up. Yeah, but that's the whole thing. Is these days you want to get stuff done, you go to it, you create a community around a foundation. You don't do it through an international standard. The international standard comes through rubber stamping. C++ has got the wrong mechanism for its future evolution.
I want to propose some counterpoints to Nico and Kate. So Nico mentioned it would be nice if we had an experiment where we break backwards compatibility in the standard. But the truth is that we have done that multiple times. If you think about Alasdair Meredith has been responsible for deprecating and removing many things from C++. Autopointer. Autopointer used to be in the standard. It's not there anymore. If you try to compile some code that was written with autopointer in a modern standard, it's just not going to compile. Autopointer is gone. And I've seen people actually have to do work to fix old code we was using autopointer. So the real question is, what kind of backwards incompatible changes are we willing to make? It's not like we cannot make any. We have to decide. And just to go back to what you were saying, the committee is pretty much who decides what's worth it or not. The companies that participate in the committee, they have large code bases. They can sort of guess, hey, this is going to be this costly. Like you could never tell somebody to remove vector from the language, but maybe removing studies aggregate that is barely used and is superseded, it's going to be deprecated and things like that, maybe it's stronger bet, right? So I don't think we have any technical or sort of like cultural position to removing things or breaking compatibility. It's just like it has to be extremely well justified and the cost of migration has to be very low, because one of the reasons why people keep using C++ today is the fact that they sort of have this implicit promise, my code will keep working for years and years. But that's not strictly true, as we have broken backwards compatibility in the past, even for language features. For example, in 17, we changed the meaning of auto with curly braces. Used to deduce to initialize a list, now deduce to whatever the curly brace is. The other counterpoint I was going to make, Kate mentioned, we cannot simply say that now all constructors are explicit and we need an implicit keyword. And my counterpoint is yes, we can. As I mentioned, there are mechanisms technically to do that. We can say in the modules are isolated. You put some sort of, marker or pragma or whatever at the top of the module. You say in this module, constructor syntax by default means is explicit. To make it open, you have to say implicit. You can do that. It's just that the committee needs to agree on whether it's a good decision, and the compiler implementers need to tell you how difficult it is to do. And some influential people in the committee, including Bjarne and the people that have created the language, are really against this idea of dialects. They like C++ to be consistent, even if the defaults are wrong. So it's also cultural, a people approach. How can you convince these people, maybe it is time we start having a dialect of the language. Maybe it's time that we sort of have the use strict of C++, where the syntax changes, but it still compiles with the same underlying representation. So technically it is possible, and people have shown that. For example, Sean Baxter's work on the circle compiler in circle language, he has all these pragmas where you can enable and disable features and change the meaning of syntax on a per module basis. The problem is convincing people that it's worth doing, and doing the work, and C++ doesn't work that way.
Which I think that's a really interesting point. Is to take advantage of that stuff, because other languages have had this kind of approach. Probably the most successful one in this respect is Python, and being able to do and say, actually, in this place we want to use or not use these various features, and actually give us a sliding window. Because what I always think of as the legacy tail, if you've got a language or a code base or anything, it moves forward, and that's fantastic, except the problem is that the back stays exactly where it is. So instead of getting a simpler language with a natural window that's kind of got stuff that's maybe 10 years old, you end up with, you have to really understand, decades of history to understand the code base. What you want is that you can say, this part of the code base is guaranteed to be written not simply with a compiler that conforms to C++23, say, but actually does not use things that we have explicitly excluded. In other words, almost like a C++ minus 13, 10 years behind. It's like, these are the things we're actually going to take out. And we've got this sliding window that we can actually compile into. And this is perfectly possible within compilers. And I happen to know that the way that Microsoft do their C# stuff allows this kind of, allows a lot of that. That's built in. This is technically possible. But as you say, it's a social thing, culture.
I agree that breaking backward compatibility is technically possible. There's no doubt about that. And there are principles we can follow. The examples where we broke backward compatibility are all, well, let me say it that way. We never removed something that is used in a significant way. We knew that auto pointer was broken when we shipped the first C++ standard. It was the last decision before we agreed on this standard to say, because somebody from some compiler stood out, I remember that, in the room and said, oh, I have an idea how we can, well, essentially, looking back, use an auto pointer like a unique pointer hiding move semantics, implementing move semantics with copy constructors. And there's a trick how we can treat that into the language. Everybody in the room, because we had a big fight, should we remove it before we ship C++ 98 or not? Everybody in the room was happy. Oh no, problem solved. It was not solved. It was a compromise, and that compromise didn't work. We had really a screwed a smart pointer, and it should never have been introduced in C++. And then Adelstein removed a couple of things, some strange base class of iterators, some composers. Hey, nobody uses them. So no, we never removed something which could cause a pain.
I've had to fix code.
Yeah.
Yeah.
But unary function, binary function is for those who implement iterators themselves. That's not mainstream. In mainstream, we have to discuss how to initialize an object. We have 18 different ways to initialize objects.
We need more.
So maybe we should fix that and then discuss about consequences.
They're uniform, so it's fine.
Yeah, it's uniform. Uniform and backward compatible. Marketing is great. And the problem is all these proposals we have are not well thought out. All big changes we had were broken because they were not well thought out. That's another problem. So, and nobody is willing to fix it. So, no, that's a problem. I would say if we would will to fix it, we would get it. And don't get me wrong, it's the price is high. We have an example in GCC. So GCC had to change the implementation of the string type with C++11. So, which meant because we broke the binary representation of a string, and that was required according to C++11 standard, because they could not use internally garbage collection anymore, or reference counting, anymore for the string implementation. They still suffer from that change, and they still hate this change. So, as I said, none of the compiler vendors is willing to break binary compatibility. None of them. And that's a big problem.
I was very excited about epochs, still am, still wish that it worked out. But I think the comment about dialects is really valid. I was teaching C++ a very long time ago when the Borland compiler knew that const was a keyword and wouldn't let you call a variable const or any of that, but didn't make it do what you think const does. And yeah, and so I had students come to me and say, "You're wrong. You told me that if I mark this integer as const, I then can't set it to 4. But look, this works fine," because they were using the Borland compiler. And it's like, I know this is going to sound a little pretentious, but I'm not actually wrong. Borland is wrong on this one. But whenever someone does something in a tool that contradicts what they were taught, they trust the tool. And so if the tool has a particular set of defaults set, like the circle thing where you can turn all the features on and off, that person's going to say my instructor was wrong, not, oh, I guess my C++ is set to a different dialect. So I do understand the anti-dialect talk because I've lived that reality. At the same time, I would like to change so much. So I'm conflicted.
Okay.
Yep.
So you make a very good point. There is design space in making dialects not surprising. For example, with the construct example we mentioned before, we don't have to change the default. We can simply force people to either put implicit or explicit, right? So changing the syntax that everybody is familiar with to mean something else is a poor idea. But we don't necessarily have to do that with epochs, right? We can make it more explicit and yeah. I know. It's a difficult problem.
So I'm gonna
One comment on that. Kate, with C++ standard views introduced in C++ 20, const correctness is anyway broken in various ways. So don't worry anymore about const.
So I despite being the second youngest person on the stage, I think I'm going to take the bold move of correcting Kevlin on some history. So you mentioned that for the COBOL and the Fortran standards, that they were largely standards where we were standardizing existing practice. But I don't think that that's actually true. And I don't think that it's ever really been true that we've had a programming language standards committee that's just standardized existing practice and not innovated and created a new standard. COBOL was a language that was cooked up over the summer that was in many ways drastically different from all of the existing languages that had been implemented, and they didn't have any implementation of it when they decided to move forward with it. They took inspiration from existing languages, but it was largely 8-10 people in a room who came up with a new thing. And I think that for the most part, that's been the history of C++ as well. For the most part, a lot of major features in C++'s history, it hasn't been it's been that we've invented a new thing in the committee, not so much that we've drawn from existing practice. And I think that begs the question,
Okay, so
is there a better model than a standards committee?
It's true that there is a bit of invention. I'm going to draw back onto the Fortran one because that one is the kind of the classic one. That one was not invented by committee particularly when 77 came around. 90 was quite a lot of invention.
Yes.
But 77 and 66, those standards were what's out there. There's too much variation in what's out there. The COBOL one is an interesting one because that also harks to a different era. And you're quite correct in the sense that it was cooked up. But why? And it's not like C++ at all, because it was the idea back then that there will be only one language in this space. And therefore, what they were doing was standard at their level of existing practice. They were taking Comtran and a bunch of other things at that point and saying, oh, we need a language that synthesizes all the benefits of these. The idea that you would end up with a multiplicity of languages in the same space was not something that people were really pursuing at that point. So yes, it was indeed invention, but at the level that they were at, they were saying, no, let's take those ideas from there. We'll take picture from there and so on. Fortran is a better model in this case. Now, C++ is definitely not the only game in town. And I don't think that we have that view. So yes, there are parallels with the COBOL committee, but I just want to let that one sit there for a moment. C++ is like COBOL. I'm not going to say anything else.
Well, we've talked a bit on this panel about that perhaps the governance model that we have is is not the right one. You know, you mentioned that, you know, essentially we have 200 people who are the decision makers for C++. And I think, Kevlin, you mentioned earlier that a lot of other languages have a foundation model. Although oftentimes it's the case that the languages that have a foundation model have one implementation or one primary implementation. What are there other governance models that you think would be better for C++, or would C++ do better as a language if it had just one implementation instead of having all of these multiple vendors?
So yeah, I think that's quite an interesting one, because exactly that point is that many of the foundation models do have a reference implementation, and so first of all, that's not exactly a bad thing. Having a reference model it turns out to be very useful. But it may also not be the right model for C++ because C++ has history. In other words, you cannot impose, again, we don't have time travel, we cannot impose that on C++ now unless there's some really aggressive marketing and corporate takeovers. That's not going to happen. So in other words, I don't think that can be retrofitted the same way. I think that's not a possibility that we could look at. Perhaps some kind of foundation model, but if C++ were to be invented today, I would fully expect it to be a foundation model in that sense, if we reran the clock from now. But where we are now, it's about as far away as you can get in that sense. And the notion of the corresponding C++ foundation idea, it can never aggregate around a single compiler, a single implementation that qualifies as a reference. So yeah, sadly, that's not going to be possible. But also, I don't think we want to make it possible because, you know, that's a timeline. So other models are necessary. Yeah.
Well, I'm a long time Visual C++ user, which is why I'm so glad there are other compilers. like Visual C++ got so much better thanks to Clang, right? And I love that model. And something that you touched on very briefly, Nico, when you're talking about compiler vendors and money, the ISO model specifically, things about confidentiality, it lets people stand up and say, this would cost us X dollars, which is like a trade secret. But they're allowed to talk in front of their competitors about things that they would not normally be able to do so. And I love the foundation model, but I don't know how that matches up with a bunch of for-profit companies in the same room saying how many people work on their library or whatever. It's not all sunshine and roses.
Well, too many cooks spoil the soup, broth. Good. That's a problem we have in C++. We have no consistent design, no consistent goal, etc., etc., etc. So one problem, I want to tell you where we are now and where we have been. In 1998, in this first C++ standard, we had two working groups running in parallel. The library working group and the core working group. Nothing else. And we were about 30 people, sometimes up to 50, but more 30 people discussing each and everything together. So we had a common understanding of everything of C++. Not every small piece, but the overall picture for everybody in the room was the same. These times are gone. When I started to document C++20, I learned what I voted for. I would have never been voted for some things because they are fundamentally broken. And the problem is, the way we work right now is that some people with some interests work 3 years on something, and either you trust them or not. And you raise your hand by saying, should we have that in the standard? Because you trust them, because nobody has any chance anymore to look into all the pieces we standardize. We have about 10 parallel groups now working on different areas in C++. And then we come all together and just have a vote. Anybody against? Well, let's discuss now. You should have done it earlier. My role is a little bit like an early adopter once a standard is shipped, because I write a book about it. I couldn't believe what we have standardized in C++20. I couldn't believe. It was a whole lot of really bullshit we did. And nobody had voted yes if they would have known on some features of C++20. That's a problem. Too many stuff. Maybe not too many people. I think there are ways to deal with 200 people to deal with smaller stuff. But we need people to know the whole thing, to have a big picture and have time to discuss it.
The problem isn't necessarily the number of people involved. It's how they're contributing. It's that for a long time, the culture of the committee was to encourage people, hey, write a paper. You want to come and be involved in the committee? Write a paper, bring a proposal, come and add a new thing. I, as somebody who chairs one of the larger groups, I can tell you that the most valuable members of the committee to me are not the people who write the papers. It's the people who consistently come up and provide good feedback on other people's papers. And if we made the culture of the committee more value the people who reviewed others' papers and made sure that the proposals are sound and validated and implemented, then we would have higher quality proposals. I think part of the problem is that everybody, there's a lot of glory to being an author of a C++ committee proposal, and the people who are involved in making those proposals happen, go from a proposal to something that gets in the standard that gets implemented, are often not given the praise that they perhaps deserve. And we don't, it's not often a team. The C++ committee, I think a lot of people don't feel like we're all part of one team. Often we're there to, drive our own proposals, and there's no sort of shared sense of ownership. And if it was more of a team effort, and we had 200 people on the team all working towards the same direction and goal, I think we could get a lot more done.
Democracy was a mistake. For the record, that's a joke, partially. But there are a lot of issues in the committee that revolve around the fact that sometimes the history of software engineering is decided by whoever is in the room at the time. And I don't think that's a good model. There are proposals that have been voted down or voted up because the people that cared about a particular domain or feature were there at that point in time. And generally speaking, it's hard for me to propose a solution. I can really point out the problems, I can point out the issues with the current model. But if you ask me what's a better alternative, it's really tough to pick one. Because you either start excluding people, you either start focusing on particular things and ostracizing some companies that might need other stuff, right? And ideally, if there were a single person who has the dictator of C++ and they knew what was the best thing for the language and the best thing for the average programmer, maybe that would be a better solution, but that's just wishful thinking. So I've heard a lot of people, myself included, pointing out the mistakes of the committee and the things that don't work, but I struggle to think of a better model given the circumstances and the history we're in nowadays. And maybe this is where you can come in and propose things.
Let me say it's something very clear. Usually, when we vote on something in the standard, more than 90% of those who vote have no clue what they vote on. It's usually worse. We vote on something where we don't have time to try it out. That's a big mistake. So we need a model where when we come up with an idea, we have enough time to discuss it, to try it out, to implement it, to play games with it, etc. We don't take this time. Sometimes we are lucky. Sometimes we come with something that was just invented and implemented on the fly and we are happy. STDJ thread was something like that. I felt very uncomfortable driving this forward. I knew we solved the problem. But the outcome, looking back, was good. But that was not standardizing existing practice. And then on the other hand, I don't know, the ranges library had 3 years of experience. And C++ standard views are fundamentally broken. They break 10 different basic principles of C++. And what is worse, those who standardize and propose it think this is a good idea because they are the experts and they don't feel the pain of ordinary programmers. So another problem we have is in this standard committee, we only have experts. Experts that don't know what they vote on. That's really a bad thing. So both has to change. Both has to change. It's not about the numbers. It's about our knowledge when we vote on something has to change. Will it? No, it will not. C++ is fundamentally broken now. Forget it. Honestly.
I want to change course a little bit.
What's this then diving into the ground?
So what role do we think the C++ committee or the C++ Foundation has in improving the story for C++ package management and build systems? Do we need a standard package manager for C++ like Rust has? Do we need a standard build system? We've talked a little bit about the diversity of different C++ implementations and how that could be a good thing and a bad thing. And what is that? Is the same true about build systems and package management systems?
Yeah, this is kind of an interesting one because historically people have liked the idea of there's a separation of concerns and all the rest of it, and we use terminology of the 1970s to justify this stuff, and there's good competition, this, that, and the other, and yeah, that all sounds great, and it's a logical separation. The problem is that doesn't reflect the everyday experience of developers. Developers don't care about whose separation is where. When developers sit down to write code, when they are thinking of a deployment pipeline, they want everything integrated. They want everything to fit together. They would like the minimum pain possible. Nobody ever says, you know what, I'd really like to have a variety of different build systems, none of which I actually understand, to cause me more pain on a daily basis because, my job's just not hard enough. I need more challenge. I'm already a C++ programmer. Give me something real. Give me diversity of platforms and representation and ABIs that are not actually compatible with one another. All this kind of stuff. It's just I want that because I don't want to develop software. I don't want to deliver. So do we care about packets? So the thing is there a need for such a thing? And the simple answer is yes. Because whenever we see that there is a straight-through path for this stuff, yeah, it makes a huge difference. Can I tell you what that answer looks like? No. Do I know how to retrofit it? No, I don't. But is that important? It's massively important, and it should be considered part of the world. Here we have a committee where lots of different vendors get together, and that is the perfect forum to say, hey, this is how a lot of other standards work. What can we do that brings things into common, that makes things easier for everyone? And that, I think, that's part of the scope. I don't think it's just about the curly brackets and the keywords.
Sorry.
Oh, no, if you're going to say something that's wrong, I'm sorry.
Vittorio, you came with a nice example saying, yeah, when we have a problem, and then we could use some features of modules, and then things would be solved. Modules were introduced with C++ 20.
How's that going?
Well, there's a question. The question is, what should be the standard file suffix for module files? If a package manager is there and answers this question, that would be great. Because then we could start to implement modules portably. So first of all, yeah, thanks for your solution. Unfortunately, it's not portable yet. And then modules are not implemented in completely implemented in Visual C++. Then everything is missing to use them in practice. So, sorry, do we need a package manager? And you know what? The discussion in the standard committee on this is, and that's really crazy. That's a déjà vu of something I had 30 years ago, 25 years ago. 25 years ago, we had a discussion in the room about standard suffixes of header files. And the decision question was .h or .hpp. We we came to a conclusion and said, okay, standard header files have no suffix at all. And then, we love to search for C++ header files in the file system. Huh? And now, 25 years ago, later, we come with the same problem. And the answer of the group is, we couldn't agree on one, but you know what? This is not the purpose of this programming language committee. We could have a recommendation, but the programming language is just syntax. Hey, these are the same people that complain and wonder why modules are not used. I can't believe what I see. I can't believe what I see, because what you say is right. It has to be easy. It has to be easy. That's it. Make it easy. And then in one of the compiler vendors says, yeah, modules are for big systems, so use a configuration management system. So CMake says, give us a standard file suffix. Oh, sorry, we don't have that yet. And hey, they shoot themselves in the foot. But the good thing is, then nobody uses modules because that creates complexity.
Oh, there is no module compatibility problem at the moment.
No, don't use it. That's it.
Nico makes a lot of good points. I think your view is a bit too dark. Like there is. Like what you're saying is completely true, right? But there is progress being made. Like modules are becoming more usable. CMake is participating in the standardization committee. Kitware is participating. That's what I meant. And nowadays you can even play around with CMake and modules on Compiler Explorer, and you can get stuff to compile with both Clang and MSVC. So progress is being made forward. But I completely agree with you. I never understood why people just say, look, I know that HPP is not as nice as IXX or stuff like that, but just pick one. Who cares, right? It's going to be better for everybody. And that bothers me a lot. One of the things that I like about Rust specifically, and I'm not the only one saying this, is even if Rust didn't exist as a language, the package manager and like the build system and cargo, which is all in one package, and it tells you exactly how things should be. It tells you this is the directory structure you must have. If your module is in this folder, the name of this module must match this file and stuff like that. It just makes everything so much easier to work with. You can just get any package and install it immediately because it's always going to be standardized. And this is fantastic. The problem is this was done in Rust since the beginning. They designed the language, designed the community to work around this very strict structure of packages and tooling and things like that. And again, it's very easy to identify the problems, but how do you fix something that has been outside in the wild for so long? If you haven't, you probably can't. That's the answer, right?
Sorry.
It's also your fault.
We have to say a little bit about it. I have to talk very carefully now. So, think about you have a working suffix, CPP, which is more or less established. Yes, we have others due to historical reasons. But one reason, by the way, we have that now is because when Boost was founded, Beeman and I sat together and discussed what should be the standard suffix of Boost header files. And one decision was, and it's not the only two involved probably, but yeah, HPP, which by the way meant Microsoft had one, because that was a suffix coming from there. We had also HXX, by the way, the X means 45 degrees plus, rotated plus, because we could not use a plus in some operating systems. Then we had capital C, which we could not separate from lowercase c in some operating systems. I think we had more. CC, of course. Yeah. I think these are the four we had. So now, a famous compiler vendor decided, instead of coming up with the usual way they do it, use a suffix like in Excel, XLS. Oh, we have a special file of that. Let's add a new letter like XLSX or XLSM. So instead of saying we have something like CPPM, like C++ module file, pretty self-explanatory, etc., they decided on IXX, which is completely self-explanatory. Again, we have nothing that mentions somehow the programming language. It's a 5 degrees rotated plus again. So what is the problem? They don't want to take the better suffix. Well, they can keep it, but they should not just agree on that we agree on the more self-explanatory suffix. In a new thing where we have no backward compatibility problem because nobody has written portable module files yet. So these are the problems we have. We have people in the standard committee, just because they don't like it, they don't switch to a more useful suffix, standard suffix, and problem would be solved. That's ridiculous. I can't believe how ridiculous that is. Sorry.
But isn't the real problem here really that if the committee had decided that we were going to pick a standard suffix, we certainly would have picked something, and some people may not have liked it, but we would have all agreed. Really, the problem is that we decided that it was out of scope, and it was out of scope of the international standard that we had. The international standard that we have just describes the structure of C++ source files, and instead of saying, okay, well maybe we should, this is still within our responsibility, we just sort of dropped the ball. There is some effort now to pick it up.
I wanted to pick up, though, on Vittorio, your comment about how Rust started from the beginning a certain way. Because beginners especially, they don't like, you can call your file whatever you like. You can put your file wherever you like. No, the name of your module, like when you say I'm defining a module, the file name doesn't have to match. Beginners, they make the name of the file the same as the name of the module, which is also the same as the name of the namespace. Like in Java, we had to make the directory structure, that com dot blah, blah, blah. But beginners liked that because you didn't have to make choices, right? Here's how you're supposed to do it. But you know where we are now? I forget the number in this XKCD cartoon, but it's like, problem. There are 13 competing standards. It's very confusing. We should make our own special how to do a build, how to do a project manager. There are 14 standards, right? That's where we will be if we try to make another one now.
I think it's not just beginners, though. I think we need to just look around and say, what other languages were inspired by C++'s approach to not caring about things that matter? Which other languages have said, you know what? I want me some of that bullshit. That predates C++ unless you've got a time machine. So, and if you have, cool, can we go somewhere or somewhere? But that's the thing, is that nobody else has ever sort of said, that's really cool, let's do that. Everybody else went for kind of C had it right. Because this is if it ends in .c, then it's a C file, that's great. .h, yep, that's great. Fortran, a little bit of variation, but not too much, it's fairly predictable. C++ came along and said, hold my beer. And it's just that no other language, everybody else has recoiled from that. Every language since. So we are going to come up with suffixes, and I'm not even talking about the whole build system, but that over the last 20 years has become normal. But even just the little stuff, it's just nobody else thought it was a good enough idea to follow it. Everybody else has chosen, and they've looked at C++ and said, we are not doing that. We need to, so in other words, C++ needs to become an example rather than a counterexample. And that's a difficult thing.
All right, our next topic, and I swear, even though I work for NVIDIA, I didn't pay somebody to put this into the topic queue. But there has been a lot of news recently about large language models and how they're going to change everything, and AI is going to take over the world. So what do you think about the role of AI in our software tools, and will it change the way that we develop code?
Has anyone here heard of Mark IV, spelled with an IV at the end, Mark IV. A couple of nods, yeah, not from people with dark black hair. Mark IV, there was no need for programmers anymore. It was just a simple matter of laying out this paper form on which you wrote the input layout and then a different one with the output layout, and then a miracle occurred and you didn't need programmers. It was great. It was going to kill all our jobs. Like my mother was worried. You know, I hear they're not going to need programmers next year. It's been okay so far.
I thought ChatGPT is the next.
So one of the things that this is one of those ones I actually found a couple of months ago. I found a talk that I did in 2016, and one of the best things about that talk, so it was in Poland, and it was in the last 15 minutes there was a good Q&A section. And I remembered I'd said something about AI, and I actually found the talk online, and it was just like, this is 2016, what was I saying? And I was basically saying, you're going to need to get better at testing. That has not changed. The whole thing is that, and how much of our code is currently well tested? Yeah, there we go. So the thing is that the profession of software development is safe, because it turns out that if you want to get something out or something usable, you have to be very precise. The ability to specify precisely is exactly what programming is about. There is, in fact, a wonderful commit strip cartoon about this, to be able to say. But also, importantly, this is the advanced option, you have to know that what you got out is what you asked for. That's testing, that's review, and all the rest of it. So all of those skills that we currently employ in one particular way are still absolutely, if everything changed to a ChatGPT-based model, there would still be a lot of work for software developers. However, sadly, one of the things that I think people may have done without meaning to in the AI space, or at least the large language model space, is that what you're now going to do is you're going to generate. I want you to think about this one. I'm going to ask for something, then I'm going to get something back, and then somebody's going to have to understand and fix it. In other words, what we've done potentially is we've turned ourselves into legacy programmers because somebody else wrote the code. Well, I don't know why I did this. Even if it offers you explanation, you don't know that personally. That's somebody else offering you an explanation. You cannot outsource knowing. So somebody else still has to understand that. And so therefore, effectively, we're all going to be legacy programmers. But I think I said that for a different reason earlier.
Who here has tried ChatGPT for programming? Show of hands. Who here has found it useful? Okay. So, yeah, useful. I still raise my hand. I would say you have to consider that this was an explosion that happened in a few months, maybe less than a year, right? And the amount of quality, the level of quality of these LLMs has increased significantly in a very short amount of time. Now, whether we are reaching a global maximum or whether there's a lot to go forward towards to, is to be seen, but is extremely impressive what these AIs can do, and I've seen them being used productively, and I've used them productively myself. For me, right now, I see them more as a better search engine in the sense that if I want to know something more particular, usually ChatGPT will give me an answer that's more useful than what Google would give me. But I've used them for programming as well. With C++, they struggle. But for other languages like JavaScript and things like that, I've had them generate working code. And sometimes I just don't care, right? I just want to get something done. I don't want to dirty my hands writing JavaScript. I just let the machine do it, right? But imagine what's going to happen a year from now, 2 years from now. I think I want to echo what you said in a slightly different way. It's not an original concept, but the job of a programmer is not to write code, it's to provide value. And the way we provide that value is by solving problems. Now, what makes us valuable and special is not the ability of remembering C++ syntax and knowing what template instantiation is the ability to figure out what the problem is, find a solution, and specify the solution in a way that's precise, that's accurate, that we can actually end up implementing in a certain way. Whether AI will become part of that process and significantly speed up a part of it, for me, it's a welcome addition. Like, I'm not scared of AI replacing me. I'm more welcoming of AI replacing the boring work. I enjoy writing the code. I enjoy writing C++ and doing all the crazy template stuff, but that's a hobby, right? My job is solving problems. And if I can do my job more effectively, then so be it.
Okay, so templates as hobby. I want to I want to lift that one out. I also want to refer back to that idea of using it as a search engine, which is exactly one of the ways that I've used it. But the funny thing I find is that it's a search engine sandwich for some things. I head out to the wilds of the internet and I search. And it's just like, okay, that's not the answer. Or I need a little more clarity, or there's far too many adverts. Then I go to ChatGPT. I get a little more clarity. But clarity is not the same as truth. So then I go back to the web to find out if it's talking complete bollocks, because now I know more about what I'm looking for. So I find there's a kind of like a toing and fro. It feels like a conversation with an unreliable partner who's is either very knowledgeable or feigns good knowledge. Well, no. I mean, those are the kind of humans I want to kind of just put a little bit of distance between me and them. But there's other elements there. I want to draw your attention. Recently, just last week, Martin Fowler on his blog, he published a piece by somebody in ThoughtWorks who used ChatGPT to generate a whole load of code and a bit of a web stack. Very, very interesting how that person went about. Zhu Hao, I think his name was. He's ThoughtWorks China. And very, very interesting how he went about it, but also the level of precision and knowledge that he brought to framing the questions and how he did it. He basically said, I don't want you to generate any code. Here are the things that I want. I want you to tell me the things that are going to matter. And there's a lot of toing and froing. He specified the architecture in some detail. But again, that level of knowledge that he was bringing to the conversation, in other words, you got the sense, it's like, this is very powerful. It's a hell of a tool. But it did not feel like a junior developer at all. In other words, it was just a reframing. As I said before, software development is safe in terms of knowledge work, and exactly as you said, the creation of value. But the expertise, it just shifts where we draw from. It shifts what it is that we're going to judge and what we're going to write. But it was really interesting as an exercise, powerful, but also kind of like, oh yeah, it's not doing your thinking for you. It's not doing all the coding for you either. Very, very clear.
One thing here. I feel a little bit like I'm starting to have a discussion I had about 10 times in my life. So can we generate programs by just describing what we want? Yeah, as domain-specific languages, there's database languages, there's NDA, there's that. I don't know how often I had this discussion. Are we seriously discussing that?
I don't know, I've been doing this since like late 70s.
That's bullshit. Sorry, can we seriously discuss about how to implement, solve problems? I hope we all agree that nothing will be able in any time, at least of my life, to generate code from a non-trivial problem which I described.
So we got a question.
Yeah, I want to make a comment on this, especially, for instance, there are many kind of systems which many people use or use if they even don't know. So, and I want those who develop those really know what's happening there. So, for instance, in financial industry. So if there's something which is not really thought through, then suddenly markets can collapse. The same is, for instance, if you are on the pacemaker, you want that the software which is running on this system for, I don't know how many years, really is designed and tested in a way that it does not have mistakes. And this is true for many other systems, for instance, on airplanes and all this stuff. Of course, there happen mistakes by human, but they are understood at a certain point. And at the moment, I have doubts that this is that the system like ChatGPT really have an understanding of what is happening there. But perhaps I don't understand those systems enough. But I have my doubts.
So I'll pose this to the panelists. So we've talked a lot about code generation, but I think that there's lots of other places in our development cycles where we might use these tools. The one that seems most promising to me is root cause analysis. You've got, a log file, and you ask the AI, "Hey, summarize what happened here," or you have a program that seg faults, and your debugger has an AI that can help you figure out what the problem was, or perhaps my favorite, you have a giant C++ compiler diagnostic that makes no sense, and the AI can help you figure that out. So do you think that tools that will assist software engineers are maybe more promising than things that would aim to replace us or to write code for us?
I think it depends how unusual the problem is. Like when the web was new, people would pay developers to make them websites. They would pay people to type HTML, okay? And if you wanted a store, it would cost you a lot of money, and someone would custom craft a store website, like from scratch. And now if you want a store, you go to, I don't know, any number of vendors, and you click a few buttons, and you can maybe even have your store for free because the code's just generated because it's a known solved problem. So if you're trying to understand compiler error messages, it's kind of in the realm of solved problem. But if you're trying to understand an arbitrary formatted log, where you say, well, here's a good one, figure out what's different in the second one, you're drifting into the not known, not solved problem. And then before there was GPT, it was other things that we made fun of their bad learning. My favorite is the thing to tell what country a tank was from. And it turned out it was basing its decision entirely on the presence of a fence. Because in their training set, I've forgotten the country, so let's say that it was an American program. All the American tanks were taken on the premises by people who were allowed in them, and all the Russian tanks were taken through fences because they weren't allowed on the premises. And that's how the AI decided whose tank it was. Because that's a simple difference between the two training sets, and you don't always know the difference between the training sets. So I think your AI could solve your compiler error messages way easier than it could figure out what's going on in your log. It would just say like, oh, there's a different font in here. That's what happened.
Okay, I've got another question. This one is one of the ones that I had ChatGPT come up with. How do you? I basically am. How do you think the C++ community should address concerns about the lack of diversity and inclusivity in the field? But here's the really interesting part of the question. And what role, if any, should the language's design play in making it more accessible to underrepresented groups and newcomers? Probably.
Say he? Be careful.
Should I say it or they?
Well, for example, I think Rust is a community that has made it a priority to make the language more accessible to newcomers. And there's some interesting ways in which that's seeped into the design of the Rust implementation. Like Rust really prioritizes diagnostics in the compiler because that's really important for newcomers. Do you think
so? The raising the diversity for C++ programmers by helping beginners would be a great progress. Yes.
I could probably do many hours on C++, inclusion, the committee, our governance model. I will just point out there is a natural tension. Like when I started programming, there was no such thing as Unicode. And once we had to do Unicode, life got really complicated for me. I'm like, meh, you're making it harder. But in the meantime, the vast majority of the planet who don't use ASCII in their day-to-day lives probably preferred that Unicode is actually a thing in programs. And so when you make things simple, you're saying, I want to make it simple for the current mainstream group that's doing it, and I don't care if that locks some of you out. And you say, no, I'm going to expand it. I'm going to let more people in by accepting different things, maybe different file extensions, stuff like that. Open stuff up to people from another operating system, but it balances back and forth. So how do you keep things simple, easy, obvious, but also welcoming to people who are not from the same background as the folks who are already here. That's non-trivial. It's not a, oh, I can tell you in 15 seconds which way to go. That's actually really hard work.
I thought that at least include CPP was a great thing, because I was not aware about how effectively and how loud we have to say, let's welcome everybody to form a message. Yeah. Well, no, well, I thought, of course, that's not necessary. No, I thought that's not necessary. And so the first thing is probably that we have to remind us and everybody else that we follow these rules and these guidelines and these etc. Oh, but also we have to be more honest. We have some issues in this community. Yeah, that's an interesting thing. Some people say maybe we have the issues because we are starting to dealing with this, and others don't deal with it. So there might also be some positive way to see things here. So the first is open your mindset. Open your mind. And to be honest, I did a few things very badly, very wrong. I learned about it afterwards. Forgive also old people who have learned it 40 or 50 years in their lives. So that's also something. Pay respect also to them. So, and that means to some extent, each of us is somebody special, somebody who is in a minority of people. So yeah, black and white, female, male is a big thing. But respect everybody, but also respect that it takes time. It takes time to learn, at least for me. I learned that I cannot be perfect from the first day of this diversity movement. I can only apologize for that, but respect it. Thank you.
Okay. So I'm not going to story top that. I think that's, you know, let's focus on the leading by example and letting people in bit, because that's actually one of the most, if people sort of see, there's a lot of gatekeeping in that community, it's not just the community, it's also the tooling. The error messages. Let's be very clear. The fact that somebody actually thinks, sorry, Bryce, that let's use large language models to solve the error message problem. That should cause you to pause for a moment and say, it's got this bad?
And keep in mind, I work at a company that has a compiler team, and I've spent the last 2 years trying to make our compiler diagnostics better.
And this is the thing. You look at different languages, whether it's Elm, Rust, whatever, and you look at the quality of the error messages, and then you try and use the ranges library. And you think, okay, nothing has changed since the 1990s. I mean, I've been told that things have changed. I can see a couple more things in the error messages that I didn't see before, but it's just like, you know, yeah, you were just pissing into the ocean here. You know, it's kind of like, no, seriously, that is an entry-level thing. If somebody sits down to just do a simple problem and they get something small wrong, they should not be bombarded with just absolute line noise and garbage that implies they are an idiot and are not fit for this space. It is really simple. That is where it begins. The respect begins with my interaction with the build system and the compiler. And if it's giving me this crap, even now, it's 2023. When did we start complaining about compiler messages with templates? That was the 90s. I'm going to be very bold here and say this has not changed. And people say, oh, but this has changed. Yeah, again, pissing in the ocean. You have not changed the water level sufficiently. It is not enough. The fact that we're actually entertaining the idea of using an LLM to tell you what, and all these other languages are going like, really? You know, we just tell people what's wrong and we point them to the bit that is wrong and we give them context and we explain it using English. You know, that just, you know, that it's possible. And the fact that a human being can look over somebody's shoulder, oh, I see what you've done here. It is actually that easy. It's not a hard problem. It is a solvable and solved problem. We begin with that. And this whole thing is like one of the things that makes a language welcoming. Clearly part of the community. There's the eliteness of cleverness. There's a danger of that. But it's just the little stuff. It really is. And it is just tidying up the language so that people feel that they are making reasonable progress without having to just get super clever. Okay, C++ programs are amongst the slowest developers on the planet. I'm going to leave that one there. If somebody wants to challenge me on it, we can pick that one up in a minute.
I have to say something here. Give me 1 minute.
No, I'm going to pass it.
It is a proof. It is a proof. The error message problem is a proof that the model that we put everything useful in the library instead of in the language has failed.
Yes. Thank you.
So thank you, Kevlin. I'm sure the GCC and Clang implementers will be delighted by your PR to fix error messages. But yeah, strangely enough, I totally agree with Nico. Like this fixation of fixing stuff in the library just creates more problems than it's worth. Going back to the diversity and like getting new people in the language, I just want to pose a question to everybody. Like, how much? It's been like 1 hour and a half, and 90% of this time has been about how terrible C++ is, how terrible the standard is, and that the language is fundamentally broken, that it's really hard to get it in a better state.
That's only me. You had also
I mean, we probably have the same opinion, we just say in a different way. But the point is it actually worthwhile to put effort and time into bringing new people, new talent to this language where, as we mentioned, there are other languages that are more welcoming with better technical sort of fundamental design of the language itself. And I'm not sure I know the answer to that. I would be happy to get new people into C++, but they need to know that they're getting into a situation that's pretty problematic. And I also guess that C++ in its nature attracts the kind of people that think that memory safety is hand-holding. You know, I don't want to do that. I want to deal with my own memory and things like that. And again, I don't know. There are better choices for communities and languages nowadays. So should we do this? Or should we just say, hey, I work in C++, stay away.
I think that we all know the quote, there are two kinds of languages, the ones that everybody complains about and the ones nobody uses.
I just want to answer that. I don't mean to sound like a Rust evangelist. I like C++, and I think that C++ has a lot of life in it and all the places where it's a better choice than Rust. But Rust is being used since a few years in production in a multitude of problems and companies. It is quite mature. It has a lot of libraries. It has a huge community. It has very big ecosystem. People are using it to provide real value. And I think that saying that it's not mature enough to be used in production is not true anymore. So I would recommend at least trying it out and see if you like it. And it is a worthwhile, I don't want to say competitor, but alternative to C++ in a lot of domains. So it's there, use it. It's not a toy anymore, and it's a real language.
I think we need to start wrapping up. I've got 1 or 2 quickest questions for you.
It's not the speed of the question, it's the speed of the answer.
That is true. So as according to this panel, C++ is doomed.
But in a good way.
What should our ideal migration path? What should people in the audience be doing to prepare themselves for the future? What should we be learning? What should we expect in the future?
So all the successor languages, which is such a weird phrase to use, I wouldn't have predicted that 2 years ago. All the successor languages interop with C++ in various, whether it's source code level or runtime interop, usually through C, of course. So there's no like panic, right? If you've got investment in code, if you've got investment in knowledge, you can move to another language without leaving any of your C++ behind. But I think the smart thing to do is to keep aware of what's going on, because if one thing C++ has shown me over all the time I've been watching it is that it will soak up good ideas from other languages. Mm-hmm. So there's no harm in learning Like, what is a borrow checker and why do I want one and what does it save me from? Because you know what? That knowledge will probably be helpful even if you never write any Rust at all. I think everything will end up in our soup.
So maybe my advice would be don't use modules, because then in future it would be harder to switch to another language.
Just kind of always just keep curious about other languages. I think I would have given the same advice 10 years ago, 20 years ago. You know, just keep your eyes open, and because it's always helpful. I think it's always helpful. I don't think it's unique to C++ or anything. I think that's always going to be the case. So yeah, keep doing that.
I would say all the time you spend learning C++ is absolutely not wasted. The sort of topics and domains that are covered by C++ are so wide and so far apart from each other that if you learn this language, it's going to be valuable for your entire career. I also want to say that the successor languages are not all on the same level. Again, Rust is used in real companies, it's producing value. People are being paid to write Rust. Carbon is something. Let's not compare it. Sorry, Carbon is not even something, it's nothing. And Circle is a fantastic showcase of expertise and technical skills. But again, it needs community, it needs support, it needs a plan. It doesn't have a plan. It still feels like a bunch of features put together, and it's crazy how talented one person can be in implementing it, but it needs an overall vision. And other things, again, they're just not mature enough. I think the only reasonable alternative I can propose today is Rust, not because I'm biased, because I like it, but just because the value is there. There is a community, there is money going around. So I would say, keep an eye out on Rust and start learning it. It's going to be a good companion to your C++, and they are synergetic. How do you say that? If you learn Rust, you're going to write better C++. If you learn modern C++, you're going to write better Rust. So
I remember those guys who 10 years ago said the same about D.
Okay.
Yeah, but the thing is, Rust, I don't remember Microsoft saying we're going to pursue a D strategy. I don't remember Linux saying we're going to let D in the kernel. I don't remember D appearing in the top 20 programming languages. So Rust is actually Rust is real. Rust is real.
Okay.
That you just look at the numbers.
Well,
we have an answer, forget.
one word answer to this one. Would you teach your children C++?
No.
I mean, if they behave poorly as a punishment.
Although I'm going to come back on my no and say I probably will do, because my older son, no, he's definitely moving away from this. But my younger son is likely to end up doing physics and cosmology. He's 17. He is on a collision. He is on a collision path with C++.
Yeah. My condolences.
I already did.
Cruel woman.
I taught my youngest C++ when he was 14. So, it's not that hard. Now, the granddaughters, they're 1 and 5. We'll see.
That was before C++ standard views were introduced.
All right, our final question on a cheerier note. What are you most looking forward to in C++ 23, 26, and beyond? Note that they all look pained.
I have an answer.
Yes.
The suffix CPPM for module files.
A lot of learning. I like learning. And despite all your doom and gloom about how broken C++ 20 is, I have been having a lot of fun learning the stuff that is new. Writing new samples, figuring out how it makes code shorter, simpler, more expressive. There's a lot to dislike about ranges, but man, you can express yourself.
Yeah. C++ is a language for tough guys.
Okay, I'm going to give you the same answer to the question that I gave in 2005 at C++ Connections in Las Vegas. There was this question, what 4 things would you like to see in the next C++ standard, I was asked. And here are my 4. A good concurrency model. Yeah, I'd still like to see that one. Proper interoperable garbage collection. Oh, C just went in reverse on that one. A standard way of doing dynamic linking. and reflection. My answer has not changed. If you want to be, if C++ wants to be able to say I'm a systems programming language, it has to be able to talk to systems. It currently covers a subset of what we, in modern parlance, would consider to be systems programming. It just doesn't talk about most of the system.
You might get one of those 4.
Yeah, I know. I got one, then it was taken away. I mean, it wasn't very well put in, but you know, I mean, I think they're kind of like virtual particles. They kind of flip in and out of existence, you know. But yeah, I might get one of those 4, but you know, I'm not a betting man.
Minor, but real improvements that actually have a chance to get standardized quickly. That's what I'm looking forward to most. I appreciate large features like everybody else, but every time we standardize one, there's always something bad about it. Concepts, modules, things like that. But I get a lot of value in my daily life out of small things that are like, hey, I used to write this code in a certain way before. Now it can be 1/10 of the size, much simpler, faster to compiler, and better for optimization. Like these sort of things I really like, and I like to see more of that.
And if you
Sorry,
want
just
to
to
see,
echo what Kate just said, spaceship. That's it. That's all.
and if you want to see what I'm most excited about, come to my keynote tomorrow. All right, that'll be it. Let's give our panelists a big round of applause.